going to learn a bit about the GPU integration work that me and my team and few partners from the CloudStack community are doing. A bit about me. My name is Rohit Yadav. I'm a long-term committer, PMC member, and ex-VP of the Apache CloudStack project. I've been also chairing the CloudStack India Group meetups for last few years now. And I've been also the member of the ASF and the Kubernetes SIG groups. And when I'm not working, I work for a company called Blue in my free time. And recently they've promoted me to be their CTO. And in my actual free time, I'm a tinkerer, I'm a technologist. I like to play around with gadgets and things like that. I'm a renewables champion. Who here is a CloudStack user and somehow has managed to use GPUs with CloudStack? Only a couple of people, okay. So I just want to kickstart by saying some support for GPU with CloudStack has already existed, but those I would term as legacy or hacks, which means you are somehow hacking the hypervisor or CloudStack in a way which it wasn't meant to. And we had some support for that. But today, we're going to talk about the GPU integration. So back in November, my colleague Vishesh Jindal, who's staff software engineer at Blue, proposed the GPU integration feature in the CloudStack collaboration conference in Madrid. And few people listened, right? So we have been trying to build support within the community, and being a diverse user-driven community, 3 of the organizations, so that's AT&T, US Signal, and Blue, and you can see 2 of us, so that's Vishesh and me. We sort of had a collaborative approach to this. We iterated, okay, what does it mean to have a GPU integration in CloudStack? And without sort of leaving everyone in suspense, this collaborated effort has resulted into the GPU integration feature, which is open now, right? So the pull request is out, it's public now, and anybody is welcome to review that, test it, and give us feedback on that. Tentatively, we plan to ship this as a technical preview in the next release of CloudStack. That's CloudStack version 4.21, where one of our release managers, Suresh, where are you, Suresh? Okay, he's at the very back. He tells me he plans to cut the RC by end of this month, so hopefully next month, that's in August, we'll have the 4.21 release. Why this feature? Well, you know more or less why this feature, but for the sake of, let's say, completion of this talk, I thought I'll mention few, right? First one is to satisfy variety of GPU use cases. I've probably discussed, I think every month I've discussed 2 or 3 organizations that they needed support for GPU in CloudStack. It's been like that, right? And it's been a crazy journey, and finally it's happening. It's also to enable CSP who want to offer GPU as an offering to their users and their customers. The other one is the AI or data locality and sovereignty, right? That's a big one. I think in the morning, Sunil talked about that. It's also about ability to have the end users self-service GPUs. You don't want to ask for permission. If you're onboarded as a user or customer, you should be able to use that. And of course, it benefits a variety of end users of GPU. Let me just quickly talk about the architecture. This is the, well, more or less the architecture diagram for CloudStack. I think Jitin also showed a very much nicer, prettier picture than this in the morning. And the only difference is that GPU is now at the bottommost layer, right? GPU is supported as a first-class infrastructure resource in CloudStack. What that enables is all the layers above the benefit out of this, right? So whether it's the CloudStack UI, Kubernetes service, CKS, EKS anywhere, CAPC, or whether it's one of your own third-party internal, external systems, right? They all can leverage this feature. This is another way to look at the feature where the management server, you can see on the left side, has an API endpoint on which you have the UI, CLI, and the third-party systems, right? It talks to the KVM agent, right, which is running on the KVM, Linux KVM host, where you have these instances which through a libvirt and maybe some other secret sauce, they get to leverage the underlying GPU hardware. It's worth mentioning in this first phase of implementation, the support for the first-class GPU feature ships only for the KVM hypervisor. Now, I have an integration demo in mind, but I don't have actual GPUs. So what we have done is, we have a GPU framework which I'll try and demo against the simulator hypervisor of CloudStack, right? And for whatever reason, if demos don't work, I have some backup screenshots, but who wants to see screenshot, right? Let's just try. So first, I'll try to demo as a normal user to see, okay, what is the user experience of an end user? So as soon as I log in, the first thing I notice in the dashboard, suddenly I see GPU, right? I can see I'm allowed to use 20 GPUs, out of which 2 are used and 18 are available, right? That's what I see as an end user of CloudStack, which has GPU enabled instances. Next, I can go to instances, and here I'll see my GPU specific instances if there are any. In fact, if I go to add instance, by the way, this is a snapshot version of CloudStack 4.21, so it will look slightly different from what Jitin showed us earlier today, right? So you kind of see different kind of use cases, right? A CloudStack operator can create new class of what we call GPU groups, template groups, right? So you can create your own template. Here you have GPU specific templates. So I've selected my GPU template, right? It's important because for the end user, we know some GPU specific drivers and secret sauce need to be installed in these templates. So you can do that. Next up, in the compute offering, you can select a compute offering which is GPU enabled, right? So we have a button, you can see GPU versus non-GPU offerings. Let me select this one. So this is just a fictitious offering which has two numbers of GPUs in it, right? I can put in data disk, I can put in my networks, I can put in SSH key pair, I can put anything, right? And all I need to do is launch my instance. The point I'm trying to prove here is for the end user, nothing changes really, right? All they have done is they have just need to pick the right template and the offering. That's all. That's all the end user needs to do. And voila, they will have a GPU enabled instance. Now, as an end user, if you scroll down on the left side, the info card, right, you'll see the GPU mentioned. So you'll see that, okay, this instance is not only GPU enabled, it's using this particular type of GPU in the offering. We also have a GPU tab. So as an end user, you can see the types and numbers of GPUs that are on the instance, right? That's more or less the user experience for the end user. The other thing you can see is, as an end user, if you go to your user specific tenant, like in this case, the user, click on limits. Here also you can see the GPU specific, where is that? Yeah, you can see GPU specific limits as the end user. And this applies to domains, it also applies to projects. All right, that's the demo for the end user. Now let's just try to log in as an admin. One more thing to sort of mention here, because GPUs are in a way tied to the compute offering, there is no specific new type of usage records, right? So an end user can continue to see their own usage and get billed by their cloud providers or CSP or enterprise provider, right? In the same way they got billed for a running or allocated instance, so they get to do that. As a root admin or an admin, now I see the total number of GPUs that are across all my zones, right? So across all my zones or a specific zone that I can select. So I've seen 6 are used and 80 are the total number of GPUs available in my deployment here. Again, same thing, you know, as a root admin also, you can click on add instance and go through everything. However, as a root admin, once you have deployed an instance, you may see something different. So if you go to the GPU instance tab here, you'll see that it's clickable now, right? The UI slightly changes. If you click on GPU devices here, you can actually see like what are the GPU cards allocated, what are the type, on which hypervisor host that GPU card is available, what is the state, it's allocated, it's managed, and some other information. So we'll talk about address and other things in a moment, but those are the things you can see here as an admin. I can also click on it. It takes me to this GPU card specific view where I can see information about GPU. GPU cards all are unique, right? So even if it is a NVIDIA H100, it will have a specific vendor ID. Those things are captured here. You can have specific profiles here. So bare metal pass-through is there. But in some cases, if your GPU supports shared GPU or GPU virtualization like vGPUs, then those profiles and different VRAM and other parameters will also show up here. You must be wondering, how is CloudStack doing this? Answer is it's done in an automated way. Let me show you how. As an admin, once you've added a cluster, you'll add a host. CloudStack will automatically detect whether this host has GPUs or not. If it has, then you'll see name of the host and it will have a tab in the UI saying GPU enabled. Let me go to a particular host. So in the host view, you will see right after CPU and memory, you will also see GPUs, right? So you can see how many GPUs this particular KVM host has. We have a dedicated GPU tab here. So from here, you can see a summary of all the GPU cards, like what are the total numbers allocated, and the instances which are using them. And if you want more detail, you can click on GPU devices. Here, you will see all the GPU cards which are on the host. You will see the profile, whether those are pass-through kind of GPU cards or are they being used as a GPU virtualization, which means that GPU is being split and used as a vGPU or MDEV device or a virtual function sort of device. You can also see managed state here. So for example, let's say I've got a server, but I don't want CloudStack to, or users on my CloudStack system to use more than 7 GPUs. So you can pick one of the GPU and say, I don't want it to be managed by CloudStack, right? Which means CloudStack will not allocate and manage the lifecycle for this GPU. You can also see the state. So when it says free, that means it's free to be allocated, right? But then there's a management state, whether CloudStack is responsible for managing that specific GPU device or shared GPU device. In the example here, you see there's one instance already running here, and you can see the specific profile. I can also click on an instance to see, okay, this is my GPU and it's being used, it's being run on a specific host, and I can go back and forth between the UIs, right? One more thing, I'm gonna just delete everything. So I can show you an interesting feature. Cannot delete because of course this GPU is in use. So let's find a host where probably no GPUs are in use. So this looks like a host where like 0, right? None of the GPUs are allocated to instances. So I'm gonna delete all the GPU devices, which is to tell CloudStack, hey, forget about all the configuration. I can manually add a GPU device if I know the name, the card, PCI device, and all those things. Or I can click on discover GPU device. What this method will do is it will fire a operator configurable GPU discovery script, right? So it's a mouthful. So operator configurable GPU script is nothing but it's a customizable bash script which basically returns an array or a JSON of all the GPU devices which exist on that KVM host. So an end user or an operator can customize the script in a way that it returns this information to CloudStack. We, as part of the technical preview, will implement something that in general will work. But let's say you're using a really proprietary high-end version of GPU, which let's say we couldn't test, right? So it allows you to configure on a per host basis. So if you have 2 hosts, one has different class of GPU, other hosts in other clusters are different. On a per host basis, you'll be able to configure this. So here you can see I've clicked on this, it discovered and added all those GPU devices, right? And automatically things will show up here, it will show up on the dashboard and so on and so forth. Let's also look at the limits for a second, right? So I can go to an account, go to any account, and I can see the limits, but I can also configure the limits. So I can give tenant specific limits, right, to enable self-service. So maybe I want to start with no tenant is allowed any GPU limit, right? So there's some global settings you can set to 0. And then for specific accounts where I need to slowly and gradually roll out my offerings to my users and customers, I can change that here. So that sort of covers the extent of the user experience that you see here. I'll go back to the slide and hopefully we will see if I missed anything. So we talked about instance deployment. So these are some global settings, right? Max cloud GPUs, domain, and project. Now there's one more niche case for our enterprise users who are not CSPs. By default, if you deploy a GPU-enabled instance and stop it, the GPUs are by default reserved and allocated to the instance, even though in the instance, the KVM instance is stopped. But in enterprise use cases where you're not billing, you're not worried about that, you want a stopped instance to not reserve or allocate GPUs. In such a case, there's a global setting where you can say, let me, on stopping an instance, detach the GPU so other instances and other users can use that. So we have that as well. Okay, I missed the offering. That's what I was thinking. Where's the offering? I think I showed you the inventory management through host, but what about compute offering? Once you auto-discover GPU cards, that's the inventory management, then comes cataloging, right? How do you catalog and your offering? It's done through compute offering, so you can add an offering here. You can put in all the details here. Automatically, CloudStack will show you a list of the auto-discovered cards. Of course, those cards you can manually add as well. So if I select any particular card, so you can see the available GPU profiles. Now this is a basic card, so I can't do more than pass-through. Maybe because the GPU card doesn't support anything other than pass-through. But if you have a modern and sophisticated card which supports sharing or virtualizing the GPU, then those are the different profiles that you can select. You can also give the GPU count, number of GPUs you want to offer. You can also say GPU display. This is for a VDI use case, right? Whether you want the GPU to be used to render your screen, so for VDI or desktop use cases, this is something what you will use. In addition to this, under configuration, we have a list of GPU cards here. So you can add a GPU card if you know the device ID, vendor ID, all those things in advance. By default, it's not necessary to do this manually because CloudStack has a GPU auto discovery mechanism here. And let's go back to our slide and see if I missed anything else. Yeah, so I think, one point of note here that generally we have found that you need to turn on some GPU specific BIOS settings, right? Those are enabling SRIOV, VTD, virtualization, and some PCI settings. We have already looked at the GPU inventory feature. Cards and properties, I think I've briefly mentioned. You can manage cards, you can add them. Profiles will try to auto-discover, you can manually add the profiles as well. In terms of host allocation and orchestration, CloudStack will continue to honor all the parameters like your host tags and any other attribute that is in the offering. In addition to this, let's say I'm trying to deploy an instance that is or using a specific compute offering which links to a specific type of GPU and the GPU profile, we'll honor this. Along with that, we'll also look at the GPU limits for the tenant, whether it's an account, domain level, or project level. We'll look at those limits also. In addition to this, we'll also look at some fine-tuned options like NUMA, right? So if you have an instance that is being asked to be deployed to use multiple GPUs, CloudStack will automatically try and find and to place the instance on a host where multiple GPUs share the same NUMA. What is NUMA? Basically, if you have a server which has multiple processors, multiple system buses, if your GPUs are on different NUMA nodes, then copying data is costly. But if they are on the same NUMA node, you'll not have those performance bottlenecks or hits. For operators, we have two customizable hooks. The first one is the auto discovery script that I talked about. So under etc CloudStack agent hooks, that's where we will put this basic inbuilt script, and an operator or a sysadmin can sort of customize it to their needs. On the right side, you can see like an example JSON response, what the script will return. Similarly, now this is not specific to the GPU feature, but it also helps, right? We have added another hook that allows anybody to rewrite the domain XML. So in KVM, the virtual machine is called the domain, which is specified by an XML code, right? And you can have some scripts apart from the Groovy-based agent hooks that already exist, right? Where you can easily write a shell script that can rewrite that XML. In terms of the usage, this is to just show you what a GPU enabled instance would look like, right? Here you can see we have a couple of instances running a dedicated GPU here. And in some cases, for example, in case of NVIDIA, we have an NVIDIA license server running there, which can split an underlying GPU into vGPUs or MDEV devices that the instances can use. More or less is the same with GPUs. It's a Kubernetes cluster that's using instances basically. So how do you use GPUs with Kubernetes clusters? Similarly, right? The only difference is typically the instance is a worker node which has an underlying GPU attached to it. How about bare metal? Well, the short answer is possible. I think the last talk in today's meetup is going to talk about an exciting new framework called the extensions framework. And I would say I'll shut up and say I'll let my colleagues talk more about this, but short answer is possible, right? All you need to do is you're orchestrating bare metals which have these GPUs. Of course, it depends, right? All features, all good laws have some assumptions and limitation, and this feature is none different than that. Some assumptions are that the role of CloudStack is limited to how well the GPU devices are discovered and being, fed to CloudStack, because CloudStack in the end is orchestrating them. The admins and users may need to customize their templates. I install GPU specific drivers in them, otherwise it will just not work. And there are some actions which are unsupported. For example, VM snapshot with memory will not work. Even live VM migration may not work for all cases. Maybe it works for vGPUs, which we are yet to test, but for pass-through, we found that it doesn't work. And dynamic scaling of instances, of course, will not work. here's the next part, which is how do you design and deploy a GPU-enabled infrastructure as a service cloud? Okay, CloudStack has the feature, but the question is, what's in it for me, right? You're all sitting there like, what's in it for me? How do I make use of this feature? So I'm going to quickly summarize and say that these are current popular GPU vendors, but our implementation in CloudStack is agnostic of a GPU-specific vendor. We know NVIDIA is the king, the top performer now, but our feature makes no assumption whether it's a GPU device offered by NVIDIA or AMD or Intel, and every one of them have a different type of GPU virtualization offering. First one is obvious, right? So what are the different types? In what different types can I consume my GPU? The first one is pass-through. The entire physical machine is passed through an instance and use that. And the second one, the SRIOV, single root IO virtualization. Essentially, you're splitting your PCI device, the GPU, at the hardware level, right, which are done by something called as virtual functions. And the third one is MDEV, which is what NVIDIA uses, where you're kind of splitting an underlying device, but using the Linux MDEV framework. This is just a comparison to show, okay, what's the difference between MDEVs, SRIOV, and FIIO. The long story short, the simple thing is this. MDEV has to do with software-based virtualization. SRIOV gives you hardware-based virtualization, and VFIO is nothing. It's not shared, right? It's not virtualizing GPU. It's complete pass-through. In terms of hypervisors, we support the latest versions of Ubuntu and Enterprise Linux. I always suggest, whatever GPUs you suggest you want to use, go and read the documentation, right? What does the GPU vendor recommend to use? We all know the different use cases of GPUs. Why I have this slide? Because it may, once you understand for what use case you're building your cloud, you can better design your cloud, as in what specific GPU cards you want to buy and put in your servers. There's certain cards, let's say on the left side, I've also included AMD Intel ones, right? It's not NVIDIA. I was having a debate with Shiv earlier, and I think these people also have a bit of game left in them. So I think shared GPU workloads, specifically if you go back here, VDI and some of the other use cases, it fits the bill. AI workload for training is a different ballgame, right? So you need a different set of chips there. There are some considerations like in what cases do I need to have GPU pass through. Anything that requires large VRAM, anything that's latency sensitive, robotics, real-time automation, those things will probably require GPU pass through. And anything that's not any of those things can benefit from shared GPUs. So whether it's vGPU, MX GPUs, or something similar. And these are all the different kind of workloads that fit the bill. In terms of challenges in future work, right now we lack the accessibility to test this feature against actual real-world GPUs, because we have tested against maybe desktop or laptop class GPUs, but it didn't have access to test some of the features like the vGPU, MIG, or even live VM migration with vGPUs. The other thing, let's say the future work would be to iterate our implementation of the auto discovery script and other implementations that you saw in today's sort of demo. And we think by shipping this thing as a technical preview in 4.21, we hope by 4.22 this will become production ready, right? Based on community feedback, testing, and reporting, we hope to do that. Other future work can include GPU-specific metrics, so you can see metrics and telemetry within the CloudStack UI and API, and maybe expand support to other hypervisors. That's it. Thank you. Any questions for me?
What is the relationship between GPU profile and our script?
So the script can return in its JSON what profiles are available, because our understanding is these profiles are created and configured on a per host basis. For example, let's say you got a Tesla V100S card which has 48 gigs of RAM. You want to use it as shared GPU. So you will configure the NVIDIA vGPU manager and say, split my 48 GB card into equal sized 4 or 8 GB RAM, right? So those configurations are done on a per host basis, and the auto discovery script will basically get all the information, feed it to CloudStack. That's how CloudStack discovers not only the GPU card, but also the profiles that are configured on per host basis.
So, so the clustering, so all the number of hosts would have the same version of class. Then only that HA will do.
Sorry, is your question about VMHA, like how VMHA will work? So,
HA overflow.
because in I think most cases, except for virtual machines or instances using vGPUs, live VM migration is not possible. So your question is how will VMHA work? Like anything, as long as there is ample capacity in the cluster, if your GPU enabled host goes down where a GPU enabled instance was running, CloudStack will automatically try to allocate it to some other host. And this is same as somebody trying to stop a instance in CloudStack and that host is gone, and then CloudStack is trying to start the instance on some other host. Of course, other limitations apply, whether, for example, um, I mean, do you, not only you have capacity, but other things like do you have the right type of GPU, because you might have heterogeneous, GPUs in an environment, and also whether you're using shared storage. So let's say if somehow deployed local storage instance on a host with GPUs, it's not going to be HA. Yeah.
So, what all GPUs are supported? The list that you showed, they're all supported in this? Or?
Yeah. So the
Question, sorry, my question is more of, is this being developed more as a framework, or are these a specific type of GPUs that are supported? Because H100 will have a different mechanism of achieving
yeah.
utilization, etc.
What we found is all of them or most of them support the same NVIDIA vGPU manager, right? They have the same things going on. So either you have pass-through or you have an MDEV based, most likely have MDEV based shared GPUs. All these, so by the way, I'm not getting paid by any of them, right? I'm not promoting any of these chips. The point was that go and read the documentation for the specific hypervisor and the list of supported chips for the specific use case, whether it's AI inferencing, VDI, or something else. Um, our implementation is agnostic of the GPU vendor and the GPU card. So it doesn't matter what it is. And we are using some common ways like scanning for PCI devices, right? And in doing that. So we have done in such a way that CloudStack doesn't care whether it's NVIDIA this card or AMD that card or Intel that card.
So, in other words, like if we have to handle, let's say, InfiniBand virtualization, that's something we can do.
Yeah. So you would use basically these transformers, right? You can, on a per host basis, not only you can customize the auto discovery script, but what happens when the VM starts or stops, or when you are configuring the XML transformer. In the shell script, you can put in your custom hooks. So let's say you have an NVIDIA H100 or maybe something newer, and not only you want to configure something on the KVM host, but you want to talk to NVLink manager or do something, you can put your secret sauce in here, which is specific to your needs.